So we have a quotient rule here, right? Function of x, function of x. There's also going to be some chain rules in our derivative. So when we take the derivative, our quotient rule is our bottom function, so natural log of 12 cosine of x times the derivative of the top function. So that's the cosine of 3x to the fourth plus the natural log of x minus the top function times the derivative of the bottom function. So that's the natural log of 12 cosine of x. And we're going to take this whole thing and divide it by the bottom function squared. So we got a natural log of 12 cosine of x, whole thing squared. All right, so when I look at derivatives, this is going to require a chain rule. This is also going to require a chain rule. So chain rule. All right, so I know that the derivative of cosine of any inner function is negative u prime sine of u. I know that the derivative of the natural log of any inner function is just u prime over u. So then when I start to rewrite this derivative, I'm going to have the natural log of 12 cosine of x as my first term. The derivative of the inside of this function is going to be, what do we got? We got a 12x cubed plus 1 over x times the derivative of, so that's a u prime right there. So there should be now a negative and then a sign of the exact same thing. So I'm just going to make this, I should do a negative sign like this. Negative sign of whatever we got. We had a 4x cubed, 3x to the fourth, plus the natural log of x. All right, so then we're going to get a cosine of 3x to the fourth plus natural log of x, and then derivative of natural log of this thing, right? So the derivative of 12 cosine of x is negative 12 sine of x over whatever's on the inside, so 12 cosine of x. All this over the natural log of 12 cosine of x squared. This is probably some stuff we could rewrite here if we really wanted to. Like if we really, really, really were being like fun, we could write that as like a 12 tangent of x. What else could we do? We could kind of take that negative and make it like a plus if we so wanted to. We could pull this negative out front if we wanted to. So, I mean, we could write it a couple of different ways. Let me just do those things because it's a homework video. So we could write this as negative natural log 12 cosine of x times the sine of 3x to the fourth plus the natural log of x times 12x cubed over, plus 1 over x plus the cosine of 3x to the fourth plus natural log of x times the tangent of x all over our denominator squared. So that would be probably a more simplified version of the derivative. And we can definitely go further than that, right? Because we could play with like these exponents on the natural logs and things like that. We could break that natural log up, but let's not be nerds.